This is John Black, super chemist. Now this next 3 minutes is going to answer every question you've ever had about relativistic mass that they won't tell you, okay? Because I'm going to define. That's what they won't do. They won't actually define, and I'm going to go over the one more mistake that they did, that they're trying to screw you over. But here's the first one I already mentioned, right? Relativistic mass equals relativistic energy. 75% of the time they put this after it. And it took, subconsciously you just don't look, even when you read it, half of the time you don't really soak it in when it's in parentheses like that, okay? And it happened, I know for a fact because it happened to me. After so long, I caught on about this, and then I went back and I looked and I was like, oh, I'm not even realizing that this is in parentheses, you know what I mean? And then part of the 70% did that. The other part of the 70%, they would say relativistic mass equals relativistic energy. Then they have a parentheses, and then they have the equation, and they put this equation with a C with this. Like, so they'd either have parentheses saying divided by C, or they have like an asterisk or whatever, and they put this formula. Like, are you kidding me? Only 35% would leave out the parentheses and the equation. So, and this isn't in mass units. It's in energy units. It can't be mass if it's not in mass units, okay? So that's one thing. They're lying. They're outright lying, saying that this is relativistic mass, okay? Because we know for a fact what relative mass is down here. We'll get to it. But so let's look at this formula, right? This is relativistic energy. Why? This is not relativistic energy, okay? It should be relativistic energy because, listen, look, this mass there, that's standing still mass is the standing still energy. Meaning this mass is the standing still mass, and then the whole thing is the standing still energy. See how that makes sense? This part of it is the relativistic mass, right? So you would think that this whole thing here would be called the relativistic energy, but it is not. See, that's the confusing part. It isn't. This is the relativistic energy, okay? This is just called kinetic or motion energy, okay? Why they did that? I don't know. Just because they're woke, I guess. I don't know. They're just crazy. They're crazy. Doesn't it make sense? What I'm saying? Standing still mass, the whole thing is standing still energy. Relativistic mass, the whole thing would be called relativistic energy, and then you call this total energy. That all makes sense. But see, they didn't do that. That's why everyone's so confused. Okay? Alright, so look down here, and then one of the last things, okay, what they did. This is the form, they told us about this E equals mc squared, told us how it's a big lie, and this and that, blah, 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 blah. And they gave us this lie, right? Okay? They use a little p, and every time the circle of the p is the same as the c, and the line goes down. It's not a giant p. Like, see how this giant p, my circle is above the c. It's a big P. There's a difference, okay? This P that they're telling us is m times v, which is momentum, okay? But that isn't true. This needs to be a big P, and that's the difference. A big P is gamma mass velocity. And that's relativistic momentum, okay? So this is correct, right? But I wouldn't even use it even because that P is just confusing, man. You need to convert that P into what it is, which is gamma mv, like I did right here, right? Now, what is relativistic mass? It's the gamma mass. That's why gamma doesn't have any units. Mass has units. It's just rest mass times gamma. That's it. Then you turn that into relativistic momentum. Then you plug it into the formula, multiply it by c. Squared or whatever. You know what I mean? Put it back in here, and then you'll get your kinetic energy, right? So when you have your formula like this, right, correctly, right, this part right here, well, this E, that's your total energy, or your relativistic energy. It's not your relativistic mass. You'd have to go up here. It's, no. It's just relativistic energy, which is the total energy. Okay. This mass here is the rest mass. The whole formula here is rest energy. This whole formula here is kinetic energy or motion energy, not relativistic energy. Okay. Only the gamma mv is the relativist. Oh wait, gamma mass is the relativistic mass, and then if you add in the velocity, it's the relativistic momentum. And then here's some other formulas if you want to look at them. But you see what I'm... This, no other video. You will not find one video on YouTube that gives you this right here, telling you how they are screwing stuff up. You know what I mean? See, at the same time, they're saying that this, right, the energy is the relativistic mass, but they also say this is relativistic mass, right? You can plug it right into EMC squared, so that means relative mass is E over C squared. You know what I mean? That makes sense. They're lying saying that this is relativistic mass, because we can see right here, even in their own formula, if you rearrange this, relative mass equals energy divided by C2, C squared. So they're lying. This is not relativistic mass, okay? It's just relativistic energy. The relativistic mass is over here, gamma rest mass. And the units prove it, because the energy units are not mass units. So then it's not talking about mass. So C is just like these. The C is just a conversion factor. This V and C's, those velocities are conversion factors to get it into joules, to get it into energy. Okay. So if you have mass and it has rest mass, it's not moving, no kinetic energy, all you do is plug in your mass and times it by C squared, and then you'll have your total energy. It's that simple. That's how easy that is, right? I want you to look down here now. Here's a bunch of formulas you could look at, right? The total energy, right? Because we had E equals mc squared, right? Well, you can take out the, if you know this was at rest, right? What if you had a mass that was moving, but you knew what the relative mass was, right? You could just take out the word m, right, and put in mass, relative mass. You know what I mean? And still mc squared, right? But you're using if you know the whole relative mass, and this thing would be moving, then you wouldn't have to use this whole formula up here. You know what I mean? Just plug it in like that. Alright, well, we showed you how to do it when you're standing still. You're not moving at all. You use E equals mc squared. If you're moving and you have a rest place, you know, you're not a photon or something, you can use it. That m is a big M. That means that's the relativistic mass. And here, this proves right here too. Look at this. This is the relativistic mass. See, relativistic mass can't be E, because it can't both be relativistic mass, right? This is relativistic energy. Relativistic mass is energy divided by C squared. You see how it can't be the same thing. So obviously I'm right. Then you got now we're going to go into something that we haven't gone into yet. A photon moving, having no, I should have said no, that should say no rest. But yeah, having no rest mass, right? Now for that one, we use this formula here, right? But can't use gamma. Can't use gamma anymore, right? So what we're going to do, right? We're going to use this formula here. We need our momentum, and it equals Planck's constant over the wavelength of the light, right? Remember, this is our formula, right? E squared equals mc squared, blah blah blah. Remember, this is a big P, not a little p. I'm using the P instead of the gamma mass velocity because it's just gamma is a ratio of rest mass and moving mass. But there is no rest mass, so there is no ratio, so there is no gamma. Okay? You can't have a gamma of a ratio of something when you don't have one of the ratios, you know what I mean? So you can't use gamma, okay? But this here, since you have no rest mass, you can cross that off, right? Then you come down here, it's this, then you square root both sides, and you get this, E equals PC. Energy equals the momentum times the speed of light, right? So P, right, equals E over C. Okay, so we rearranged this, right? And we got P equals E over C. Okay, and we know already, right, that E equals HF. Okay, that's just another equation that we just know. So, if we do this, right, we take the HF and replace that E. Now we have HF over C. Then, here, the speed of light is the wavelength times the frequency. That's just the you know, that's a law. And I just keep rearranging them, right? Here I divide both sides by F, so then that way I can transfer my F underneath the C. And I have, I don't know what that is, probably lambda maybe, equals C over F. And then I inverse or flip both of them. Now I have 1 over gamma equals F over C. Okay. So look, we have an F over C here. If we replace that with a 1 over lambda, we'll end up with H over lambda, or the Planck's constant over the wavelength, right? And that gives us our momentum, right? P. So let's put the units in, right? Here's P. The J comes from, so that J seconds comes from the Planck's constant. The M is meters, comes to the wavelength, right? Now I changed the joules into this, kilograms. You can see over here. I changed it to kilogram meter squared per second squared. And I brought the second per meter over here. You can see it's red and red. Then I canceled out. I got kilograms per meter second. And as we know, momentum, P, is mass times velocity, kilograms meter per second, right? So this is our momentum, right? M times V, kilograms times velocity, right? Now, what about our energy, right? E equals PC. We got our P right here, right? The meters per second is the units for the, C, speed of light. And if we multiplied them, we would end up with joules as our unit, which is E. That's our overall total energy, okay? If you want to call it the relativistic energy, it is, because it's the total energy, okay? And where do we get that? Remember, E equals PC? Where do we get that from? The original, E equals mc squared, the whole formula written out. We crossed off the rest mass part of it. Now the momentum is relativistic momentum and relativistic energy when we're talking about photons or moving, speed of light. Why? Because let's say this photon is moving to the right, right? It's going from here, going this way, right? Well, what if you're also going really fast though, but you're going the same direction? This is the same as throwing the ball at each other, This is the same thing as you throw a ball at someone. If they run towards you, it's going to hurt more than if they're running away from the ball. If you're running with the ball, the same, going to the right, it's going to redshift. It's going to have less energy, right? If you're just standing here looking at it going, and it's going by you, you're not even moving. Now it's just green. But what if you're running towards it, but you're running real fast? Now it's blue. You got less energy, more energy, even more energy. It depends. It's your vector of the frame you're comparing the light to. It's direction dependent on what this is, how much energy it has. It's not that the photon changes its energy like magic. Okay. The relative thing is what this would look like, or what this would feel like if it hit you in the face. Okay? Alright? Now, if you're running you're running with it,